Hello everyone, this is Bradley. So today this is a voice recording to make this spider web simulation inspired by BBBN19, who also made it in simulation nodes 3.6. The main purpose today actually is to test the Jiggle Deformer again, because once we solve this jiggle part, the rest of this animation should be quite straightforward. The principle should be very simple. To make my life easier, I'm going to use Blender 4.0. So let's start. So here we're in Blender. As always, I'm going to use the presets, which you can download for free from the link in the description. And by the way, as far as I know, BBBN19 never really discussed how he made the spider web simulation, which means I may use a completely different approach from him, but you never know. But the principle, in my opinion, is pretty simple. You have a point which you shoot rays, and you construct the spider webs based on this result, and you crush this spider web into a single point, and you animate the recovery of this spider web, and you add a jiggle to this recovery animation, so that you have a kind of a bouncing back and forth effect. It sounds to be very weird, but as we progress, you may realize what I'm actually talking about. So let's start. So firstly, we need to start with a curve. So let's start with a curve line. And I need to set the position start and end. So end point selection, the starting point may be better to be defined by an empty. So we're using the start size 1, and we take this empty so that we can control the start location. So it may not be very obvious, but I'm having this curve right now. Let's reduce the size of this empty. Okay. And I need to shoot rays somewhere. Actually, I can just set the position, and we take an end point. And we define the location on our group. I need a group input, our group input geometry. So to do that, let's just give a kind of random vector. Actually, let's combine x, y, z. So we create a vector towards the x side. Actually, this is y side, because that direction is y. And I vector rotate it. You can do however you want. Actually, it really does not matter. So we take a random rotation, maybe just 1 radian, and we take this position. And we set a geometry proximity, or yeah, geometry proximity should be fine. And we sample the face, so that's essentially we're snapping a point onto it. So we're using a position to add on the top. With this vector rotate. and I hope it's working. Yeah, we can see the spline is actually shooting to the initial geometry we have. So it is working. And I'm going to duplicate this point or this curve. So we duplicate the element. So we generate the splines. We have this duplicate index. We get it into the custom ID. So that every spline is getting a different rotation. So that we create a kind of web kind of structure. Okay. Yeah. So now we've done it. And next step is essentially to create kind of other parts connecting to the mesh and other parts connecting to each other. So here let's basically we generate points onto these splines. So let's take a point instance, but we are selecting points because we will generate lots of curves for no reason. Firstly, let's take a curve line. And we just give a kind of full random rotation. And we can visualize it. We can make this curve line quite small. So take a randomness and we take a value precision so that we divide this random value by 10 and plug that to scale. You can see it becomes quite small. And we basically resample it so that we generate points on these curves. And basically we use the proximity to ask this curve to look apart on the geometry. So let's take a geometry proximity. To itself and plus our initial geometry, and we work based on the points or face. Maybe you want to subdivide our mesh too, so that there are points to set the position. So we realize the instance and we set the position. We need to control the end and start. So we only affect the end to be proximity. So now we have such kind of effect, and we can join it to see. And it does not really look very nice, but we get sort of idea. One thing that you need to realize is that it says the curve is not being supported. So we take curve to mesh so that it will be supported. So now we have this kind of effect. You can see some of the splines, they goes to the mesh, some of them they go to itself, hopefully. So we take a random rotation, we just give a more values. We increase the count, and it's supposed to be 360 degree. By increasing the length, you can see the result. So we're creating this kind of effect. It's not really, I don't know. I think I completed because it's not 100% completed yet, because you can add the strands to the others. So instead of using this join geometry, if you select only this curve to mesh for the geometry proximity, you can realize that there's points are trying to get onto each other. I think Oh, because we didn't resample it, so the points will not be each other. So now if we look at it, so it becomes like this. Okay, so resample for both evaluation is kind of important. And I do not really need this many curves. Let's just take a random value. So we use a random boolean to decide maybe only half of the amount of points we resampled will generate a whatever stuff. And you can also do a lot of things. For example, maybe spline parameter will not really generate stuff when it's too tiny. So if it's greater than so now you can see we're limiting the generation based on the length of this curve. So these are things that you can do. It does not really matter. It just tweak parameters and add the settings as you want, but the main point is that you need to create this kind of result, and we may add some more amounts as well. So you add this kind of result and we basically crush that to the point. So we have this geometry. This is the spider web, and we can use a join geometry so that we isolate this spider web without a mesh, and we set a position. We set all points to converge with the position we have. So this is the starting point. So we mix its position with the starting point. We can use this controller, or you can pull this controller information from wherever it is before. So now by manipulating this mix, you get this kind of a shooting effect. Okay, so this is kind of idea, and we join geometry so that we can see both plane and whatever stuff. Okay, so this is my idea. But up to now, this effect is really kind of boring. We will add Inertial Deformer, but before that, we need to really complete this animation. So we take a map range. You can keyframe this, but here I'm just going to use a kind of cheating method. If this is same time starting from 1, and it will give a value from 0 to 1. So now we have this effect. I can also color ramp or float curve so that we initially have close to 0, and then it becomes very fast. So once we completed this, we can add a inertial deformer, and I discussed last time we can add a set position to mix with the desired location and the inertial position, and we add an oscillator, which is a sine function, and we take the sine function without the clamping factor. So now if I take this frequency and we add a decay. So if I add a decay, so you can see how this curve is going. So now if I look at it, if I play this animation, so you can see it becomes like that. There was an overshoot and you go back. Right now, this animation looks kind of very boring. There are several issues. One issue is that it definitely overshoots across our wall, which is not realistic and not desired at all. So one is we are going to clamp this value. The second thing is I want this endpoint to stay so that it gives you kind of the illusion that it's really stick on the wall. So let's firstly visualize this factor. We can see this inertial position, which is overshooting, and this is the desired position. So to construct the design function, we basically want to limit this factor as small as possible. So we add a kind of a clamp. And maybe I limit at 0.1, but the minimum value can be -1 because I do not really care how much it draws back. So we get something like that. It becomes a little bit more realistic, but we still have a general effect to entire spider web. So to resolve it, we're going to add some limiter. So we multiply a value to it. And since we're working with the endpoint of whatever onto the wall, so we can say that I'm going to add an endpoint selection to it. So I'm going to select anything which is not at the end of these curves. So now we can actually see some effect. It may not be very obvious because everything is very fast, but you do realize something is changed. And we can increase the amplitude, and maybe it becomes okay. It gives you more sense, I guess, but it's not very obvious because we clamped this result. Maybe we increase the maximum a little bit more. So I hope you can actually see how things are different because of our changes. But this is basically it. There's one more thing I'd like to do now. Currently, everything is go linear straight from the starting point to the end. And you see this, everything is basically a straight line. It's kind of very boring. So we add some curvature to make it more kind of a Spiderweb-like. So let's add a kind of a center position of our geometry so that if I have a center line and I try to drag all this kind of spider web to this central line so that we can create a kind of curvature, not only to deform the shape, but we can also animate this kind of spreading effect, as we will see. So to do that, firstly, I need to resample the curve. And previously, we already did to resample this curve. So we just replace it. Okay, we use this resample curve for everything. And then we're going to use this resample curve to construct some values. So let's capture an attribute. And we need a center position of these points. So this is what we're having right now. And because it's being resampled 132, so we can take a curve points preview to see the actual amount of points we have. And I'm going to calculate an average of each group of points. So the end points will be 130 seconds, and that spline is 130 seconds, and that point is 130 seconds, that point is 130 seconds. I'm using this 132 as a group index so that I'm calculating the average of these 4 points, and I repeat from this the first point to the last point. So this is accumulated field, and we use this spline parameter index as a group ID to calculate an average of its position value. Then we use this total amount to divide by the domain size, because we need to get the spline count. If I have 4 splines, it gives 4, and I capture this value. Okay, so now if I look add this vector. We can export this vector to our final mix, and we can slide this value. You can see it's not really working because we need to have a viewer. So now you can see it's actually working. Something like that. So this is the effect we're having. There are some issues because of the points is not sticking to that. But for now, I would say let's just stick with this effect now. Okay. And we can mix this relationship with our previous controller. So that initially we're starting from this 0 point, and then we shoot out a ray, and then we use a second factor to control the spreading out of this spider web. Okay. So basically, it means we just need a different interpolation of these two animations. So now, if I play this animation, you can see this is how it looks, and we can make this animation a little bit faster. It becomes too fast, maybe 15, so that we can have a better or larger magnitude of inertia. So this is what we see right now. Okay, and as I mentioned previously, that we are going to use this center point to actually drag the position of our geometry to make a kind of a tension of this spider web. And we basically do that. So we have this captured attribute. We just do that afterwards. So let's capture attribute. Not capture attribute, we set a position. And we do a kind of mix. Remember that currently we're working with the 4 initial splines because we haven't really diverged with instance yet. So we take a mix vector. We mix this position with our capture the center point, and we define the position. And we use a spline parameter. Actually, we have the spline parameter. So now it becomes like this because this value goes from 0 to 1 from start to the end. And I'm going to remap it with a float code. So that the endpoint is not being affected with our mix, but the center point will be affected. So I think it becomes like this. It depends on how you map this curve, but maybe something like this. So it becomes more like a kind of spider web. And you can change your interpolation so it becomes more extreme, or it becomes less extreme, more diverse, or something like that. Anyway, you get a kind of idea, and then you just play this animation. You can see it becomes like this. And also to note that the amount of points is being used to instance your spider web, which means if you increase the counts, then there are more whatever stuff will be created. And if you do not see the logic behind this spider web, it becomes more like kind of spider web, if you understand what I'm saying. So, okay. There's one more thing that we can do today is to add some noise or turbulence when our spider web is actually moving to this wall. So we add a set position, we can add a noise regime. It may not really make a difference if you add before and after, but I'd like to just add a new set position so that this change of position can be calculated inside this position vector. So now we have this again, this kind of overshooting effect and so on. We can do the same with endpoint selection, but just to make it a little bit more accurate, I'm going to construct a proximity fold. So we can use the geometry proximity, and we are calculating the distance to its face, because if a point of the web is on the wall, then we will have a position value. So let's capture it. It's not necessary to capture it. Or actually, it might be better not to capture it, but you never know. So we can actually tweak this fourth. As you can see, the black area, which means 0, it means if I apply this fourth to the fourth, then there will be no noise. So now if I increase the scale of this noise, you can see the endpoint actually stays on the wall. So this is what we're getting now. And you can increase the frequency. And a second fourth I want to add is a timer that once this overshooting effect is over, then the noise should be cancelled as well. So we can add a timer using our delta time. So let's give it 8 frames, and we make our noise from 1 to 0. Okay, so now if I play this animation, it becomes like this. Kind of weird at this moment, but I hope you see the idea. And we can add a time info to keep wiggle our noise. So maybe factor to 5, so it becomes like this. We have a kind of turbulent effect along with our wiggling. It's kind of very organic, despite the fact that the initial point is being wiggled too. But we can fix that very easily if we construct another fourth capture attribute before. Maybe we can do that. If I store a named attribute, let's store a named attribute. Let's just call that spline parameter SP. At the end, let's conclude 2 important lessons from this video or this experiment. First of all, parameters are important. I can teach you the concept to make an animation, but I cannot teach you the parameters because there are limited possibilities. It's pointless to give you a specific setting. For example, right now we have this kind of a spider web. We worked for maybe about 20 minutes from the starting of this tutorial, but we can change the seed just very easily. It becomes a completely different setup. And I change the seed. And we can also change the variance of this random rotation, so it becomes more spread out. Another thing is that we can increase the amount of duplicated elements, so it becomes like this. Completely different. So you can tweak the parameters. Okay. You have to do this by yourself. I cannot teach you. I can take years just talking about this spider web, while no one really cares. And the second thing is that this is the principle of this setup is very easy. We have a spider web setup. It can be very ugly or whatever, and we are animating just a linear fashion, just the start end, very simple. But we add a inertial deformer so that we have kind of wiggling events occurring somehow. Okay, which looks kind of cool. This means that you can use this kind of concept for every geometry you have, not only the spider web or different spider webs. If you have ever watched a reference from Houdini tutorial about the Spider-Man animation, he spends about at least 20 minutes out of a 50 minutes tutorial just talking about how he constructs a spider web. He added many different systems. For example, he's connecting all these kind of points together, and he's adding a second layer that starting from these branches, you have a more organized shooting out whatever stuff being created and so on. Currently, we only have one layer, and it's made out of the same principle. I'm just shooting line to whatever places which are available. This is very disorganized, kind of ugly, chaotic, but it's very quick. It does not really spend many nodes to do so. It's just some instancing and random value. So basically it means that you can polish everything as you want, but the principle of this animation will not be changed. You just tweak this mixing and inertia in the way you want. And at last, again, parameters. So I probably will just stop here today. I hope you enjoyed this video. I'll probably see you next time. Bye-bye.